So, I'm going to be talking to you for 10 minutes or so about mathematics and why I am convinced that it is a beautiful subject and that maths can be considered an art. So, I'm having a look at this kind of traditional view of mathematics, and you'll see here examples of what a lot of people think of when you say the word maths, and it causes a bit of anxiety, and people kind of get a bit worried about having to do calculations and so on. And I don't think we do ourselves many favors in teaching by producing stuff that looks like this, because aesthetically it's just horrendous anyway. But it's also, it's just the same thing over and over again. So it doesn't really help our cause to convince people that there is kind of beauty within this subject. But similarly, there are examples out there of people trying to convince people that there is a natural beauty in mathematics, and that mathematics is everywhere, and there are links between things in maths and nature. And while that can be true, more often than not, it's not really backed up with some of the more popular sort of what I would call fallacies. And this is a classic example. So this is the golden spiral. You may have seen it before. It's typically used to depict a sort of tool to show how it's used to show beauty in various things, and it's used in architecture supposedly to ensure that there is balance and make it look particularly pleasing. Like it's the way to max out the beauty in something. And this is, you can find this in a lot of textbooks. You can find people doing YouTube videos on this and so on. And it feels nice, and it feels like something that you kind of want to believe. But in truth, it's pretty nonsensical. I mean, you could take this spiral and put it on anything and convince people that it belongs there. So here's an example that I've produced. This is obviously a very beautiful dog, even though it won, I think, ugliest dog competition a year ago or something. That's so Google tells me anyway. But just by rescaling that golden spiral, lo and behold, you can justify that it fits on it somehow with like the curve of the mouth and the I guess eyebrows or whatever. It's silly, and it's one of those things that's persisted but completely unnecessarily. And I think it does an injustice to things that genuinely are beautiful in mathematics, because it takes away from them. Here's an example of something that is beautiful in mathematics. So this is called a fractal, and this particular fractal is called a dragon curve, and it's like a self-generating pattern, if you like. It's you take a pattern and you keep doing it and doing it and doing it, and it kind of self-replicates in a way, and it produces these really fantastic images. And there are millions of different types of fractals and examples of fractals in nature, everywhere, and it's a real shame that these kind of get passed over in favor of things like the golden rectangle and the golden spiral and so on, when I think genuinely there's much more obvious and real examples of maths, beautiful maths, right in front of us. So here is another example. This is called a random walk. And a random walk is assigning randomly a direction for a kind of pen to travel in, if you like, up, down, left, or right, and you just keep doing it and keep doing it and keep doing it and keep doing it, and as long as that you're traveling the same sort of distance each time, and it will create, unsurprisingly, a random image. But they look really cool. They kind of look like fractals, and they can create some really, really strong imagery and quite abstract, but I think it's quite beautiful to look at. I've got an example here of someone doing this kind of thing for a display in their classroom. So they basically rolled a die and decided which direction to go in and so forth, and used two different colours and created this really interesting imagery. So I'm going to take a slight tangent into looking at minimalism for a moment. Here's two examples of movie posters using a minimalist approach, and the reason I want to talk about this for a second is just because I think this really transfers to why I find mathematics and a few other things that might seem a bit abstract beautiful. There's a lot of key ideas and themes around minimalism that transfer to mathematics, as we'll see shortly. So here's an example of a puzzle that I've created. This is geometry, and I don't want to go into any depth about what this puzzle is, really, but just by looking at it, you can see that it's influenced by minimalism. And part of my kind of strategy to write these things is that I kind of have a tick list in my head about what I want it to do. And priority number one is that it looks beautiful, and it looks like it doesn't necessarily have to be a maths problem. You can just stare at it and find pleasure in just kind of looking at it because it's so simple, and it's not confusing to look at. There's nothing to distract you from it. I just find it really, really appealing. Here's a second and final example of geometry stuff that I do. Again, just trying to keep it really, really simple. But even if you don't want to approach the problem, even if you don't want to do the mathematics behind it, it's nice to look at it. You can appreciate what it is. So can we take this concept and apply it to less obvious examples within maths? I think it's quite easy to tie in geometry, but what about things like algebra and so on? Well, I think this equation is kind of ugly, so we'll move on from this example. But if we take those principles of minimalism, to me they are efficiency and elegance. And I think it's important to note that elegance usually means like it's simple but not necessarily easy. Simple doesn't mean easy in mathematics. It tends to mean the complete opposite. And promoting a positive reaction. Prompting a positive reaction. You're looking at it and something, it affects you in some way, in a positive way. And you develop an appreciation for it as well. So I'm going to give you, just to finish, a couple of examples of how that manifests for me in mathematics outside of geometry. So here's something that I posted on Twitter a while ago now. It's just a simple subtraction. 43 take away 17. Do it in your head. What method or methods did you use to do it? And by all means do that. But I'm going to take you through a short number of examples so that you can see and hopefully start to feel that appreciation for the elegance in some of the solutions that come through. So here's the first one, 43 take away 10 take away 7. So we've split that 17 into two different things. I think that's one of the more likely ways people would approach this, but there are other ways. Here we have 43 take away 13 take away 4. And I think this is slightly more elegant because we're looking at trying to make this thing simpler to do in our heads. And by taking away that 13, because the units correspond to what we're doing, what we started with the 43, it makes it feel easier. And furthermore, here's another example. This time we're taking away 20, which is more than we need to take away, but then we're adding 3 on. And I think that's quite a novel approach, and I like it. I like it a lot. And it makes the maths even easier, arguably, and it's a more elegant solution again, I would say. And finally, I love this example too. So we started with 43 for the question, but we're adding 3 on to that to get 46, so that we can subtract 20, which is a really nice thing to do in our heads. It's not too difficult. Very, very quickly then, just to finish, this is an example of a proof that I did in a book that I wrote. On the left hand side, it's like brute force algebra, but on the right hand side is someone else's approach to the same thing, and hopefully you can see the difference between just mathematics and mathematics that is elegant when contrasting the two methods. The one on the right is far more elegant in my opinion. Similarly, this concept of elegance can go outside of mathematics. I see beauty in things like programming. This is Scratch, so it's kind of a child's version of programming. But both of these programs do the same thing. But you can see the one on the right hand side is far more elegant than the one on the left hand side. And again, I apply this view to things like climbing. I like climbing, and if you look at this, you have like a bouldering wall. Some people might just see it as a big pile of different things to grab hold of. But for me, there's elegance in choosing the right route and deciding upon the most effective route to take that will get you to where you need to go with the least effort. So thank you very much. I hope you've enjoyed that short talk on the beauty of mathematics, and I hope I've convinced you somewhat that there's a lot more than meets the eye, and that you can view this as something that is artistic and stunning, beautiful.